Okay, what are we going to be talking about today? Well, this is going to be for the true devotee. I'm going to close up here, get a little privacy. Yeah, everything's working. Okay, going to have a little fun today. We're going to talk about things we've observed. Things that we've observed that has led us to conclusions based on the way we think as human beings. Okay, some of the things we're going to think. First of all, I want to talk about things that just my peeves, like in science fiction movies. Okay, artificial gravity. You always see, that's one thing that movies have. That's always a good backdrop for an artificial movie, is that the spaceship is going through space, and it has this, you'll always see it like in 2001 or something, Space Odyssey, where the big rotating event is going on. Kind of like if you have water in a bucket and you have centrifugal force and you're throwing it around. Well, in movies, space movies, we see where is this big thing is going around. This spacemen or the astronauts can walk around on the inner level of this thing, and as long as it's going around, they've got a artificial gravity, and they can sit at a table and drink coffee and stuff like that. Okay, well, a spinning object like that. Well, of course, that's false, right? And there is no artificial gravity. We haven't figured that one out because it would take something on the scale of something as large as the moon, basically, to give you gravity, even if you want to call it artificial gravity. But those are interesting points of our concepts, and this is an example of how we can misconstrue ideas, how we can put ideas together, but they're not good. And this is how the human mind works. It can have good ideas, and some of them are really super and pretty interesting, but they're false. Our dreams, our imaginations are not true imaginations. They are compilations of things we see in the universe. Okay, now what I want to talk about this morning, and I'm trying to lead into it with this artificial gravity thing, is that when you watch space movies or you watch stories that people have come up with, and here in this day and time we have a number, I get a kick out of. But one of them I was watching not too long ago, I was watching a Star Trek, and they had their spaceship going, and they found a void or a hole in space. There's another foo-paw. I mean, the definition of space is a void. So you can have a void in a void. Well, okay. I mean, it's not that it's impossible, I suppose. It just doesn't apply to the rules we work with, nor to our language and definition. Under the Socratic method, which I believe in, and I think that's part of the way our human mind works, is that a void within a void is just stupid. Okay. It's a redundancy. So you might as well get rid of the one. Math tells us that too. Okay. Now what we're going to talk about, though, is what I saw in the Star Trek movie. And what was it? Jean-Luc Picard was commanding the ship, of course. And he told whoever's in charge of the controls, to go ahead and hold his position in space. Holding a position in space, and right away, you first come to the conclusion that isn't that kind of stupid, in everything in motion in space? How the hell are you going to hold your position in space? But when you think of it, when you think of it, it would be considered possible to hold your position in space. That you could take your rocket ships and hit retro rockets, like, say, if you're in the space shuttle and you need to make a descent, and you're in an orbital path at a speed of probably 17,000 miles an hour around the Earth. All you have to do is hit your retro rockets a bit, and you slow down. And by slowing down, you will enter a closer orbit to the Earth. And as you enter a closer orbit to the Earth, of course, you'll be positioning yourself then to be much more affected, because of inverse square, we think, of what we call the attraction event, or gravity. But gravity is kind of a misconception. But there's this event that we will definitely, like magnets, start heading towards and wind up on this very large other mass. Okay, so here we have Captain Picard holding, and I forget which episode this is, but holding the spaceship, holding a position by a void in space. Now, can you hold your position in a void or in space? That is there such an event where we could hold a point in space? And I believe that fundamentally there is. Of course, Newton worked on this when we talk about inertia and what inertia is. Now, of course, in calculus, in Newton's approach to inertia, it was the idea that a body, when you acted upon it, didn't want to go anywhere. So it was holding its point like a top spinning, and that has a lot of force to it. We think about that, and when we're thinking about an item that is spinning up, it does want to hold one positional relationship along the axis. But is it possible to then hold a position in space? Can man, we know that in nature we don't see this, but it doesn't mean that it's not possible within the physical laws of nature. We may even be able to define what is holding your position in space, so to speak. And that's one of the things we really are interested in, because it is getting us back to proofing why we would consider the idea that precession is the third law of physics, or it's one of the fundamental events we have to take into consideration. We may not even want to call these laws anymore. That may be taking us in the wrong direction. But we know that we need to consider in our Socratic method of trying to understand the world we live in. Well, there's the ringer. It made me jump. And what we'll go ahead and do is end this on the Socratic method on precession in holding your position in space. Okay? Until next time.